electric field due to a uniformly charged thin plane sheet. So here we want to calculate a thin plane sheet. Okay, so it is a uniformly charged plate. So we can draw the diagram. It's for a uniformly charged plate. It's a thin plate and we are considering a positively charged plane sheet only we are considering, and we want to calculate the electric field at this point. Suppose if we want to calculate the electric field at that point, we want to draw at the Gaussian surface. So here you can draw the Gaussian surface here, and here also on both the sides, and it should be a Gaussian surface, means it's a closed surface only. And now our aim, you want to find the electric field. So for finding the electric field, we want to apply what the Gauss's theorem we want to apply. That means the integral vector E dot ds is equal to how much? Q by epsilon naught. So our first point, we want to calculate what will be the closed integral vector E dot ds. So we want to calculate the integral E dot ds, we can represent that as, okay, integral, that means we can write as integral E dot ds, that we can represent in terms of three regions. So the first region you can consider, this is the first region, and this is the second region, and here we can consider the curved surface, we can take it as a third region, a small area we are considering. So first we can find out what will be the area vector. So this is the region 1, this is region 2, and this is the region 3. So we can calculate the area vector. How we can draw the area vector? It should be normal. And here if you are taking the area vector is always acting in the outward direction. And here also it is acting in the outward direction. So this and all, it's the area vector. Okay, vector ds, vector ds. Now we want to find what will be the direction of the electric field. We know that electric field is acting in which direction? It is acting radially outwards. It's a positive charge, means it is acting radially outwards. So it's a very thin plate. So the electric field in this region is acting like this. Here also it is acting in this direction because the electric field is acting radially outwards because it's a positively charged plate. And here also, but here there is a difference, is the electric field is acting in this direction. So here we can write the three angles. We can represent here theta is equal to how much? 0. Here theta is equal to 90. And here theta is equal to how much? Again it is 0 only. So now this equation integral E dot S, now you can make it into three regions. The one region, region 1, E d s, what will be the theta? Theta here it is 0. And the region 2 means this one only, that only we are taking as region 2. So that is also E d s cos 0. Then what about the third region? So third region is, again it is E d s cos, what about this angle? Angle is equal to 90, so we can take it as cos 90. Okay, so that is cos 90. Now we want to find out this, again you want to simplify this, and you will get that is E integral ds, the region 1. Cos 0 is 1, and here also E integral ds, that is region, here it is region 2 is the, so region 2 ds, and the region 3 here, now it becomes what? Cos 90, it will becomes what? 0. So here we can write E, and from the diagram we can show that the total this area we can take it as what? Suppose this all area we are taking as A, and this area also we are taking as what? A. So if you are taking this, then you can substitute integral ds, we can substitute as what? We can represent it as EA plus this is also EA. So we will get 2EA. So that only we derived from this equation, that is integral closed integral vector E dot ds is equal to how much? EA plus EA, that is 2EA. So now we have to apply the Gauss's theorem, and from the Gauss's theorem we can write what integral vector E dot ds is equal to how much q divided by epsilon naught. So what is integral E dot ds that we already calculated? That is 2EA. So we can substitute 2EA is equal to how much? Q by epsilon naught. So from this we can calculate the value of what? Electric field. So what will be the electric field here? Electric field E is equal to, we can substitute as E is equal to Q divided by 2 epsilon naught into A. Okay, q divided by 2 into epsilon naught into E. Again, we can write the another term that we call it as sigma. That sigma we call it as the surface charge density. That is charge per unit area. That we call it as the surface charge density. So here we can substitute what is q by A. That we can substitute as sigma. So that is electric field we can represent it as sigma divided by 2 epsilon naught. So this is the electric field due to an infinite plane sheet.